before I start?
Yeah, this is the protein factor, right?
Yes.
Should we be getting the file like when I read the assignment we were getting it through the URL? Should we download the file first?
Yes, you can download the file first and have it in the same folder. Okay.
Well, but I mean, is it only for that one PDB file, or you could?
Let me see. Okay, so the question is asking you to write the file using URL write into a file. So you're going to have MATLAB do the downloading for you. Okay. And it would make sense to not download it if it's already in there. Okay. So let's do it. Let's download this file. Control C. So for the URL write function, you need to provide a URL and a file name. And it will download that URL and store it in the file name that you specify. And then we can edit that file just like we are editing any other file in MATLAB. And we see its contents. Okay. One of the common mistakes when you work on this homework problem is to hard code the PDB ID, let's say 1CRN, instead of taking it as input. So your function will be provided with a variable that contains the name of the PDB. And you need to construct the URL from that variable. Constructing the URL from that variable is simply concatenating a string vector that contains this first part all the way to this slash, and then the variable, the input variable, and then another string .pdb. Okay, so that will give you the URL. And then you will do the same thing for file name. You will concatenate the variable with .pdb. And it makes sense to save the file name in a different variable. Let's call, let's say file equals pdb.pdb, assuming pdb is the variable that is given to your function. Okay? All right, so we'll do all this in this problem where we are asked to read the PDB file and extract the atom coordinates from that file and return it as an n by 3 numerical matrix. All right, function m equals PDB coordinates, and we are given a variable that contains the name of the PDB. So URL is going to be this, and the file name that you would like to store it is going to be that. So I need to construct the URL from that first part all the way to the slash character, and then the PDB variable, followed by .pdb, store it in the URL variable. Next, I have a new variable called file that will contain the concatenation of the PDB variable, followed by .pdb. I'm going to call the URL write with URL and file. Okay. Now let's look at the contents of this folder. PDB chords 12AS. That's another PDB. It's going to take a little bit, but MATLAB is downloading it, and it's in the current folder. Okay? But next time I run PDB chords, it will again download it, and your function will run slow because every time you give a new PDB, it's re-downloading that file. Assuming those files are not changing, and you are not really interested in any changes in those files, in those web pages, you can wrap this URL write with an if statement that will say only download when that file is non-existent. Okay? How would you check if a file does not exist? Exist function will tell you. So instead of the second argument that we conventionally use, which was VAR, so with this VAR, you are checking whether file is the string contained in file is a variable, but now we are interested in a file. Okay, so we are asking whether the file contained in this file variable exists, and we need to say not exist because we only want to download it if it doesn't exist. Now it's running faster, right? Let's delete this PDB and run this again. It's going to take a little bit, but then it'll download. But it downloads only the first time. Okay, so this will speed up your coding because you don't want to wait for a download every time you want to run your function. Okay, so now let's look at this PDB file again. It's a text file, but as far as you are concerned in your MATLAB program, it's one large string. Okay. There are two ways to work with a file like this. One is to read the entire file into MATLAB, into a MATLAB variable as a string, and then operate on that string. The other, which is more applicable to very large files, because if you have a very large file, it would not fit in MATLAB's memory. What you would do is read the file line by line. Okay. All right, so reading the entire file is easy. I'm going to show you how to do that first. And then we will also look at the second way of reading the file line by line. So there are some common operations that you need to perform when you are working with files. Bless you. So the first step is to open the file. Okay. The function that you are going to use for that purpose is called fopen. F stands for file, and then you are opening the file. You need to tell which file you are opening. So you need to provide the path to the file that you want to open. In our case, we stored that information in the file variable. Okay. And you also need to tell fopen how you want to open the file, meaning what you are going to do with that file. Are you going to read from it, or are you going to write into it? If you are going to read from it, you need to say single quotes R. Okay. That means you are opening the file to read from it. If you want to write into it, you would say single quotes W, which will open the file for writing. But we are not going to do that in this example. We are only reading the PDB file. But sometimes you may want to output some information into an external file. In that case, you would use W. If you use A, that will append to the end of the file. All right. So normally, if you open with W, it will open that file and start from zero. It will empty that file first. So you will be starting from scratch every time you call W. Every time you call the fopen with the second argument W. If you call fopen with the second argument A, it will keep whatever is in that file. And next time you have a write operation, it will append to the end of it. Okay? All right. So we open the file, but we need an identifier. We need a way to refer to that file that we just opened. Fopen path, comma, read. So fopen will return an identifier, which is usually an integer. Let's store it in a variable named FID. You can use any other variable name, but FID is one of the common variable names for this purpose. Okay. All right. So now FID will contain sort of a handle, an identifier for the file that you just opened. Whenever you want to read from that file, you need to use this FID. If you open the file with write permissions, then you would again get an FID, and you would, whenever you wanted to write into that file, you would need to use that FID. Okay? All right. We'll take a break in a minute. There's a function called fread. The first argument is going to be the file ID that you just got from fopen. It will read from that file. There's a function called fgetLine, fgetL, which will read an entire line from the file. So you would do, after you open the file, you would perform one or more of these file reading operations or file writing operations if you opened it with write permissions, write. And then when you are done with the file, you would call fclose to close the file. All right? And again, you provide the file ID. Make sure that you always close the file that you opened. What happens if you don't close it is, let's say you open the file and then you go to your Explorer window, you try to delete that file. Your operating system will complain that some program has that file open and you cannot delete it. Okay? If you lose this FID because you don't know which variable you stored it into, or your program crashed and without getting a chance to close all the file identifiers, you can use fclose, and as the second argument you would provide string all. It will close all the open files. Okay. So if you run into the problem where some files are open and you cannot close it, just write fclose all. It will close all of them. Okay. All right, so let's take a short break and see how this will apply to the PDB coordinates problem in MATLAB. And apply the concept in MATLAB code. Okay. All right, so we will open the file first. Fopen file, R. We are opening it to read it. And it's usually a good idea to do error checking, meaning you want to check whether that file identifier is valid and whether MATLAB opened the file correctly. If this file does not exist, or your MATLAB does not have permission to open it, then FID will be invalid. And if you look at the documentation for fopen, it will tell you that FID will be -1 when it does not successfully open. So let's check if FID is smaller than 0. Then let's print I was not able to open the PDB file. And let's set a default to M to be empty and return from the function. Okay? So we opened the file, we did some error checking. Next, let's read the entire file. Let's look at the documentation for fread. If you provide the file ID without any size, it will read the entire file. Okay? If you want to read only a certain number of characters, let's say the first 5 characters in the file, then you can provide the second argument to be 5. It will read 5 characters. When you are reading from files, there's a concept of file pointer. Okay. So every file ID has a file pointer associated with it, and that specifies the position of the file identifier within the file. So if you have a very large file, the first time that you open it, your cursor, just like the blinking cursor that you have in your Word files or in your MATLAB editor, it will be at the beginning. Okay, it will be at the first location, right before the first character. When you do fread 5 characters, you will get the first characters returned from fread, but your cursor will be right before the 6th character in your file. Next time you do fread, it will read from that point onward. And fread will keep moving the cursor to the place that you can read next from. Okay. You actually can manually change the location of this cursor by using pause function. You can look at the documentation on how to use it. You can move to the beginning of the file, to the end of it, to any location within this file. All right. If you want to figure out where your cursor is currently, you can use the ftell function. It will tell you where the cursor is currently located. Okay. All right. So we'll use fread. Let me just do it in the command window first before I move the code to the file. We'll do fread and store it in fid variable. And you can see that it has the value 3. But we are not really concerned about what value it has so long as it's not less than 0. So this if statement will be skipped because fid is greater than 0. Next we'll do fread and store the result in a variable named s. Okay. Let me open the variable s. And you see that it's a double matrix. It's one long column vector. Okay? So these are the numbers corresponding to the letters in your file. Remember, every character has a corresponding number to it. These are the ASCII numbers. You could convert the variable s to a character array. Then you will get one long column vector of characters. It's a convention in MATLAB that strings are row vectors. So we'll take the transpose to fit into that convention. Okay? All right. So your entire file, which was multiple lines, many number of lines, is now a single row vector. And you need to pay attention to the difference between lines of characters and rows of characters. Okay? So all of these lines of characters are in a single row, but they are separated, these lines are separated with new line characters. So right at the end, there's a new line character, which is between your lines when it's in one row vector variable. Okay? All right. If you do s equals new line, and there's no easy way to say a new line in MATLAB, I like doing this, sprintf new line. That will give you one long logical vector where it's true whenever you have a new line character. Okay? So we get 49,248 elements. It's a logical vector, and it will contain true wherever there's a new line character. All right? So now I need to look at each of these lines one by one and see if they fit the definition of an atom that's down here. So for every atom in the protein, we have a line like this. It starts with atom. It has an identifier, a number. It tells you what type of atom it is. So this is nitrogen. This is alpha carbon. This is carbon, oxygen, beta carbon, and so on. The name of the amino acid that it's inside. So every amino acid contains multiple atoms. That's why you have the first amino acid, which is a threonine, the second amino acid, which is another threonine, and the third amino acid, which is a cysteine, and all of the atoms contained in those atoms, okay? In those amino acids, all right? We are not really concerned about which amino acids contain which atoms, but the question is asking us to look at alpha carbon atoms. Okay, let me see. Where was my question? Yes. Extracts all of the atom coordinates. So we don't even care whether they are alpha carbon or other types of atoms. Okay, so after the amino acid number, we have the coordinates of the atom right here. The PDB format will tell you where this coordinate starts and where it ends on each line. Okay? So it'll be character number something to character number something, and let me read this to see where they are. So characters 13 to 16 contain the atom type. 31 to 38 contains XYZ coordinates, and that's what we are interested in this exercise problem. Okay. All right. So we have this variable s, and we know where the line we know where the new lines are. We need to split this long vector into multiple lines. Your midterm problem had a very similar example to this. Let's write the code here, and then we'll run it. Control C to copy it, and Control V to paste it. All right, so I'm going to call find to get the locations of the new line characters. I will create a lines cell array, and for each element in capital I, I'm going to add that line to the lines cell array. Okay. All right. Just like in the midterm problem, it's convenient to add the 0 and number of elements in S plus 1. Okay, so I added a fake new line before and after my string. Another way to handle this is to change S directly and add a new line before and after it. So for I equals 1 to number of elements in capital I. Instead of capital I, let me say new line location. So it's a variable name that makes more sense. So for each new line location, what I'm going to do is look at the one before and the one after, and take the set of characters in between. I start from the second location because I added a fake location 0 at the beginning. So S new line looks I all the way to, I minus 1. I could probably start from 1 and say I plus 1 all the way to new line looks I plus 1 minus 1. And I should go up to 1 before the last location. So this selection, this indexing, will give me a line from the string S. And the for loop will iterate over each line in the string S. And let's just add it to the end of the cell array lines. Okay. Let me put a breakpoint here. so we can make sure that our function works correctly up to this point. Let's say fclose all to close all the open file identifiers, and one CRN. I didn't put a semicolon at the end of something, so we get all of those. Let's put a semicolon right there and rerun our function. Fclose all that. All right, now the lines variable is a cell array where each string, each element contains 80 characters because the PDB file contains 80 characters on each line. Okay. All right, now I have the entire file line by line in a cell array of strings. That's easier to work with than one long character array. Okay. Since I read my file, I'm not going to do any more reading from the file. And as soon as you know that you're not going to do any more reading, you should close your file. So this is the place that you would close the file, because after that point, everything is in memory. You're not doing any more reading from the file. Okay. All right, now we have our lines. We're just going to write a for loop that looks at each line individually. Number of lines, line equals lines, curly brackets I. So I selected the ith line from lines cell array. I need to check whether it starts with the word Adam. Okay. So if str compare line 1 to 4, if the first 4 characters match the string Adam. Okay. Another way of doing this is to use strnCompare function, which will compare 2 strings, but you also provide how many characters you want to compare. Okay. So you are comparing line with the word Adam, but you are only comparing them up to 4 characters. So why is this better? This is better in case the line vector contains less than 4 characters. Then you would run into a problem if you say line, take the first 4 characters. So if you try to do indexing on line and select the first 4 characters, you would get an error if line contains less than 4 characters. strnCompare will perform necessary checks. It will first check if line has more than 4 characters, at least 4 characters. And similarly, it will check the second argument to make sure that it has at least 4 characters, and then it will compare the 2 strings. So if it has, if this line starts with Adam, then I'm going to take characters 31 to 38. That's the x coordinate. 39 to 46 is y coordinate, and 47 to 54 is z coordinate. And because of a limitation in our homework page, you are asked to use str to double function instead of str to num function. So we'll take 31st to 38 characters and convert them to a double. Okay, so that will give us the x coordinate. Next, I'm going to take the 39 to 46 characters. That's going to be my y coordinate, and 47 to 54 is going to be the z coordinate. And I'm combining x, y, z coordinates into a single vector. Okay. So line is a string. You convert it to a number using str to double, and you do that for each of the x, y, z coordinates. Concatenate them into a vector, which will give you a 1 by 3 vector. Let me just call it v. Okay. Or if you don't like long lines, you can store these individually in X, Y, Z. And then you can create your vector like that. Next, I need to add these coordinates to the end of the variable that I'm returning. So capital M END plus 1, comma, colon, add it to the last row, add an extra row to it, and say equal to V. Or we could just say get rid of V and store XYZ as another row in M. But at this point, 1:3 is not going to work. Just putting a colon will not work when M is empty. So initialize M to be empty. Because we have not specified the number of columns, we could do that by saying 0 by 3. So you just tell that you specify that M is going to be a matrix with 3 columns. Okay. And all right. Let's run it and cross our fingers and hope it works. F5. Let's look at the contents of M. It's a 3-column matrix, and let's double check with the contents of the file to make sure that the X, Y, Z coordinates of the atoms match. So 17, 14, 3 is the first atom, 17, 14, 3, correct. 16.9, 12, 4, which is the second atom's coordinates, and so on. Okay? Any questions? Okay, so this is the end of the solution. But I told you that I would solve it in a different way than just reading the entire file into a string. So let's do it that way now. Okay, again, I will open the file, but now instead of reading the entire file into a string, I'm going to read the file line by line. I'm going to have a while loop that says so long as I have not hit the end of the file. So f(EOF) is a function that will return true if the cursor is at the end of the file. So remember, the cursor would move every time you read from the file. If you read the entire file, you would want to know if there's anything more to read. f(EOF) will give you true if there's nothing more to read. Okay? So long as there's something more to read, I'm going to get the next line by calling fGetLine function. Since I am reading the file line by line now, I don't need to split it into multiple lines and then go over that cell array. fGetLine will do the splitting for me. So let me delete this portion. Okay. So I open the file, and so long as I am not at the end of the file, I'm reading the next line. And if the first 4 characters of the line is Adam, then I extract the XYZ coordinates and add it to the end of M. Let's run it again. I got 0 by 3 matrix. The error, my mistake is that I need to say not end of file. So long as I am not at the end of the file, I should do more reading. And now I'm getting the same answer. Okay, M is, I have 327 atoms, and I have the XYZ coordinates of each one. All right. So if I change this problem and say say that only return the coordinates of the alpha carbon atoms. Okay. What you would do is, in addition to looking at the XYZ coordinates, you would also look at the atom type, which is characters 13 to 16. So if I have an atom type line 14 to 16 will contain the atom type. And then I need to check whether the atom type is Ca. Let's get rid of the blanks. Atom type equals blank equals empty matrix. So I'm removing any blanks that may be in the atom type. And then if str compare atom type is Ca, then get the XYZ coordinates and add it to the end of my matrix. Okay. Now I changed the problem, I changed the function in a way that it will only extract the atom coordinates for the Ca atoms. Okay. Now M is 46 by 3 matrix because I have 46 alpha carbon atoms in this PDB file. Any questions? Are we good for the homework problem for next week? Okay. This second way is easier than the first way because fgetLine takes care of splitting into lines for you. All right.